In this video, we're going to look at percent increase and decrease. When a quantity increases or decreases by some amount, it's common to describe the change as a percentage of the starting amount. And this is the key idea of a percent increase and a percent decrease. So we're going to look at a particular example here with a cereal box. But I want to really emphasize here, this is by some amount. It doesn't mean it's going to be by the same amount. And that's a characteristic that we're going to see of repeated percent decrease and increase in later sections. That if we repeat a percent increase or decrease, it will not necessarily be the same amount of percent increase and decrease. All right, so let's take a look at this example. So let's say we have 450 grams of cereal in a box of your favorite blueberry flavored cereal. That doesn't sound great to me, blueberry flavor. I don't know. One day you're delighted to find that the box now comes with 20% more cereal for free. We can represent this scenario with a diagram. And note that 20% of 450 grams we could write as 0.2 times 450 grams, which is 90 grams. So we could multiply this out to figure out what 20% of 450 grams is. But we want to show this with a diagram. Okay, so here we have 450 grams, and I have this diagram right here. Now, notice this is the 100% of the cereal. Let me highlight this. Let's do blue for blueberry. How's that sound? Okay, so here is 100, I guess stay inside the lines. Here's 100% of my blueberry cereal. Now, why is this cut into 5 chunks? 1, 2, 3, 4, 5. Well, the reason is because I want to represent 20%. And so 100% divided by 20% is 5, right? There's 5 20% that would make 100%. So by taking the 450 grams and dividing that into 5 different chunks of 90 grams apiece, that means each of these 90 grams represents 20% of the total. All right, so 20% of 100, or 20% of 450, like we set up here, is 90. And so that's why we have 90 grams. Actually, this says milligrams, but it should just say grams. Let's cross these out. This is grams. That's just a typo. I think it's correct in your book. Okay, so 90 grams would be 20% of your 450 grams. Okay. So now if I'm going to increase by 20%, well, that means I'm going to add on another 20%, and we already know that 90 grams is 20% of 450 grams. So now if I add on another 90 grams, I'm adding on another 20%. So now I have 120% of the original amount, which is going to be an extra 90 grams of cereal. All right, so without doing the calculation here, we've kind of described the situation. Now there's lots of different ways to calculate how much cereal would we have now? How many grams of cereal would we have after this 20% increase? So what we want to do in activity 1 is we want to look at the total amount of cereal in the new box, and we can express that in a number of different ways. Discuss what each expression describes down here in each of these expressions here in relation to the figure, and circle any expressions that describe the total amount of cereal in the new box. Okay, so I want you to pause the video and think about what each of these expressions would represent, and circle the ones that would represent the amount of cereal after the 20% increase. All right, let's see how you did. Well, this first one, 450 grams plus 90 grams, yeah, that's how much is going to be in the new box. I have 450 plus another 90. That would work. Could I take 450 plus 20% of 450? Well, 450 was what was in the original box, and this is the amount that's added. So yeah, that would give me the amount in the new box. That would work as well. How about 20% of 450? That's only going to give me this part right here. That's just going to give me the amount that was added. It's not going to give me the total amount in the new box. D, 120% of 450. Yeah, that's going to work. 120% of the original amount. And that's what we see up here in this diagram. 120% of the original amount will give me the original amount plus the extra 20%. How about E? Yeah, that's going to work too. I mean, these are basically the same thing, just with 120% represented as its decimal representation of 1.2. How about F? 6 times 90. 6 times 90. Well, we got 5 times 90 gives you the whole, right? Because we talked about how 20% goes into 100% 5 times. So 6 times 90, that would work. That would give you the 120%. Now you might say, well, which one of these ways should I do it? The answer is you really should understand all the different ways. Not just one way, right? Be able to think about things in different ways, because sometimes maybe one way will be easier than another way. And just really understand how all these things are giving you the total amount in the box. If you did all these computations, you should get the same thing, which would be the 450 grams plus the additional 90 grams is 540 grams. That's the amount of cereal in the new box. And every single one of these computations will result in 540 grams. All right, let's try another example, except this time we're going to do a decrease. So let's say that a sporting goods store had 64 hats in stock on Friday, and by Saturday the number of hats in stock had decreased by 24% or 25%. We can represent this scenario with a diagram as well. Okay, so let's check out this diagram. Let's think about what's happening here. So where's my original total number of hats? 64. That's here and here. 48 plus 16 is 64. So there's my total hats I started with. Now 25% of 64 is in the note here. 25% of 64 hats you can get by doing 0.25 times 64, which is 16. Another way you could get that, since if you take 100% and divide it by 25%, you get 4. In other words, 4 25% go into 100%. We could take this diagram and think about splitting it into 4 pieces. So cut it in, let's see, cut it in half and then cut it in half again. And then I'll just write it in this corner here. Each of these would be 16. So 16 plus 16 plus 16 plus 16 is 64. So these 3 16s make 48. This 16, 16, and 16 add up to be 48, which represents 75% of the amount of the original amount of hats. Okay, so now we got to go to the next page. You might kind of have to flip back and forth here. Number 2, the number of hats in stock on Saturday can be expressed in a number of different ways. So this is Saturday is after the 25% decrease. Discuss what each of the expressions describes in relation to the figure and circle the expressions that describe the number of hats in stock on Saturday. All right, pause the video and go through these and circle them. Super important to pause the video and think about this by yourself. I know you can just keep running the video and then just see what I wrote, but that doesn't help you. You have to think about these on your own. So pause the video and give it a try, and then start the video after you've had a chance to think about it. All right, let's go through these. A, 64 hats minus 16. Yeah, that'll work. 64 is the total. Take away 16 will give you the 48. How about B, 64 hats, take away 25% of 64. Well, as we discussed, 25% of 64 is 16, so yeah, that'll work. That'll give you the 48 hats you have left. How about 25% of 64 hats? Let's look at the diagram. That's just this piece right here. That's just this piece, 25% of 64 hats. That's 16, so that's not going to give you what you have left on Saturday. What is that going to give you? What is that telling us? Yeah, it's telling us like how many we lost, or maybe how many we sold, because it was from Friday to Saturday. I would say they probably got sold. Maybe we shipped them to another store though, I don't know, but that's the decrease. All right, how about 75% of 64 hats? Yeah, that's going to work. That's what we have left. We lost 25%. We have 75% left. It's kind of the glass is half full way to think about it. How about E? Yeah, that's basically just D, where the 0.75 or 75% is written as its decimal equivalent of 0.75. How about 3 times 16? 3 sixteenths. Yeah, 3 sixteenths will work. Remember, 16 is 25%. So 3 sixteenths is like 3 25%, which is the same as 75%. So that will work as well. All right, great. Make sure you understand all these different ways to think about it and how it relates to the diagram. So this is the idea of percent increase and decrease. We've included a couple more examples here for you. The first one is showing a percent increase. So think about the 100% being what you start with, which in this case, Elena has $50 in the bank, and she had 56 on Tuesday. This is a 12% increase. So you're adding that 6 on, and then we have to figure out 6 is what percent of 50, and that's 12%. And you could get that number if you're not sure. You could say 6 out of 50. What percent is that? And you could punch that into your calculator, which would give you 0.12 or 12%. But I would say, hey, let's work smarter, not harder here. If I multiply the top and bottom by 2, I get 12 out of 100. Well, that's 12%. Percent literally means per 100. So $56 is 112% of $50. And we have the $6 representing a 12% increase. Okay, and then we have our percent decrease example. This looks to be the same example as we had here with the hats. Okay, so it's always assumed that the whole, the 100%, refers to the original amount. That's super, super important thing to think about. In the first case, or Elena with her bank here, the original amount she had in the bank was 50. That's the whole. With the hats, the original amount was the 64. And then it got smaller. So let's write this out. I want to show you this. So the original in this case was 50, and then the new was 56. This is going to be important moving forward. This was the original amount. This was the new amount after an increase. Now in this case, we had 64 hats. That was the original. Then the new amount of hats after the change was 48 after a decrease. So notice you can't just say, oh, the original amount's always the bigger or smaller number. It depends whether you're doing an increase or a decrease. So what you want to focus on is whether it's an increase or decrease. If it's an increase, the original amount is smaller. If it's a decrease, the original amount is bigger. And identifying this original amount is going to be super important because it represents 100%. So notice here the 100% is the 50, and notice here the 100% is the 64. And that's really, really important to identify when you're working with percents and calculating percent increase and decrease.